In this video, I am going to provide you with a method that could be referred to as a fail-safe method for creating accurate and precise intersection points for polygons or 4-sided, 5-sided, 6-sided objects. So here we have an 8-sided object, and then we have a center point here, and then we have the angles coming off to get the intersection points. And the circle provides us with a method to get the intersecting points right where we need them, because if they're off just a little bit, as I have in this example here, then we could have a problem. So you can use this method to double check your, if you're going to build, let's say, a gazebo in the backyard or a 8-sided deck, something like that. And you want to make sure that everything is precise and perfect, because if it's off just a little bit, then you could have problems with your roof, you could have problems with your handrails, and on and on. Now in this example here, I went ahead and moved one of the lines here so that you can see what I'm talking about, where we have a longer measurement here and a shorter one here. And then this, of course, would be, this number represents what the line should be, the measurement for the outside points. Now the biggest problem with this is how do you fix something like this? Most carpenters just simply split the difference here and make a point and hope for the best, but that might not always work. Now I want to go to a square, just show you a square. Now a square, you don't really need this method with a square, because you can you're going to have two parallel lines here. You're going to have a line here that is going to be parallel to the line over here. So if the measurement's off just a little bit, for example, if I measure this from here to here, and I can see that it is a little shorter than 9 feet, then I know I got a problem. So I can simply move it. Now I'm not saying, if I measure this right here, I don't know which line to move. Do I move this one or do I move this one? And most of the time you're going to be able to check that with you. If you just cross measure these, you're going to be able to see which line you need to move. But that isn't going to be the case all the time if you come to something that's going to have more than 4 sides. So let's go ahead and start with a center point. And a center point would be from 2 lines. And of course you can have these lines where they're not going to be perpendicular, but it's going to be nice to have lines that are at a 90-degree angle from each other, like we have here. Draw a circle, whatever your dimensions are going to be, and then you can create your object from that. Here we have a 6-sided object, and of course you can use the degrees to find the intersecting points, and then use the circle to double check those points to make sure that everything is lined up. Because if this happens, and again, you might not be able to see this as easy, and you could actually have something that is all messed up in here. But if you have a circle, it's just not going to happen. The circle is going to provide you with a method that you can use to see where the problem actually is. No problem here, no problem here. Here's the problem. And we can draw a 60-degree angle. That's 60. And of course that 60 degrees is going to be from this line here. And this of course would be 60 degrees here. And to find our intersection point. But again, with our line coming across here, if you just drew these lines, you just went ahead and put your 60-degree angles in here, you could end up with a situation like this. It's happened to me plenty of times. But once I have my circle in here, I can see there's a problem. And then I can compensate for it and be done with it. So that's it for the video. The main point I wanted to hammer home, I think I did in the video, is just that the circle is going to provide you with a method to double check these points. And if you can have everything lined up perfectly where you inside the circle, then it's going to make building the rest of the project a lot easier. So starting with a nice polygon, equal sides, correct angles is just going to, project's going to go fit like a glove. You go to cut your roof rafters, your handrails, other parts, maybe even structural beams, something like that. And they're all the same size and all the angles fit together perfectly. The job's going to go together a lot faster and look a lot better when it is done. In this video, I will answer a question that I received. Someone wanted to know what a stairway would look like at a 45-degree angle. And 45-degree angle is simply going to be nothing more than a diagonal line across a square. So here we have a 10-foot by 10-foot square. And of course, here is our diagonal line. So 45-degree angle, just going to be a diagonal line connecting the corners of a square, not a rectangle. A square is something with equal sides and 90-degree angles for every corner. So a rectangle would be something if you had a 5-foot side, and then this one here would be 8-foot different sides. So it's a square, and 45-degree angle is going to be at both ends. And this is what your stairway is going to look like. And the problem created, of course, from the steps, the tread depth and the riser height is going to be exactly the same on a 45-degree angle, making it a problem, or should I say creating a problem for most of your building codes and local building departments. So here we have the same measurement. If this was going to be 7 inches, this is going to be 7 inches. And don't forget that our riser, the maximum riser height for residential stairway construction is 7 3/4 inches. And that would not work for the tread. The minimum distance for a tread is 10 inches. And that probably won't make the building inspector happy. So again, if you're just looking for a means to get from one place to another, you don't have a choice. Do whatever you want. Use 8-inch steps and 8-inch risers, 10-inch steps and 10-inch risers. Just make sure that you have a handrail there. Remember, this will not be a safe stairway, but you might give you something that you can use. So again, 10 inches by 10 inches, the same measurement for the tread and the riser. And another diagram, I'm going to leave the little lines in here. I just divided this up and divided this up, and here we have the lines for our stair stringer, just to give you an idea. Sometimes a picture is worth 1,000 words, and in this case, here's 1,000 words. This is kind of what your stairway would look like at a 45-degree angle. The depth of the tread and the height of the riser will be exactly the same. So 45-degree angle won't work. I would imagine most stairways are between 30 and 38 degrees, maybe 40 degrees, but 40 degrees could be pushing it. So anyway, I hope it helped. I hope this answered your question. Now you know what a 45-degree stairway looks like. And for those of you who didn't know what a 45-degree angle was, now you know that a 45-degree angle is simply a line that would connect to two sides of a square that were exactly the same measurement with a 90-degree angle. So a square cut in half diagonally is a 45-degree angle and will not make most building inspectors happy.